Hi, this is Math 2231 remote delivery for April 23rd, 2020. The topic is use substitution in definite integral. When I count my blessings, one of the blessings is that I saw the real Last Dance and the 5 championships before that. I remember watching Michael Jordan sitting on my couch eating potato chips, and some nights the ball was not going in the hole, and Michael would just keep shooting and shooting and shooting. And I remember thinking, Michael, this isn't your night, pass the ball. But Michael did never keep shooting. As I've gotten older, I realized Michael is right. Never quit shooting. He knew he was good, and he knew eventually the shots would start going in. He missed many shots during his life, and he kept shooting, and he made many shots. That's why I ask you to work the problems, because you learn from your mistakes. We can do this. Teaching and learning is continuing unabated. Grades are being earned and will be rendered. Your educational goals need not be deferred. Stay the course. That's what champions do. Here's an example 1. You know what to do and when to do it. Let's see how you did. Well, based on last time, I hope you were able to march along with this being your substitution. And then, based on the lecture where we evaluated definite integrals using part 2, I guess, of the fundamental theorem of calculus, you said, oh, and I will do this and this, but not so fast. If that was the path, you would have gotten less than 1/3 credit for the problem. You see, the steps were right down to here. Because you see, writing dt here means that the limits have to be values of t. But if you change the variable to u, if this variable is u, the limits have damn well better be u values. Similarly, when you write this, if this expression is in u, the limits had damn well better be u's. That's the big lesson from this part of the lecture. So please hang on to that. And let's proceed with caution and do the problem correctly now. You could have not done the use substitution at all and just directly guessed that, oh, this is what the antiderivative is. And certainly when you take the derivative of this expression, you will get the integrand. That's one of the key lessons that we learned earlier. So you see, this is t as the variable, and the limits are t. This expression is t, and the limits are t. It's complicated substituting the numbers in, but when you do, you get this expression. Now, some of my students would tell me that's an ugly number, but there's no such thing as an ugly number, just like there's no such thing as an ugly baby. This is the exact answer, and in normal times, this is the answer I would expect you to provide for me. So this is a way to do the problem without use substitution. Or you can do it this way. I got paid quite a bit of money for many, many years doing math, and I was a practicing mathematician, and this is the way I will do this problem 10 times out of 10. Because you see, when you evaluate a definite integral, the answer is just a number. It didn't matter how you got there. So what I would do to do this problem 10 times out of 10 is I would do the use substitution just like we talked about earlier in this problem. But then I would also pay attention to the limits. Students must be mindful of the limits. So as t goes from -2 to 0, what happens to u? Well, I substitute in here. When I put minus 2, I get 33. And when I put 1, I get, or excuse me, and when I put 0 for t, I get 1. So as t goes from minus 2 to 0, u goes from 33 to 1. So now I will do the problem correctly this way. Here the variable is t. I'm going from minus 2 to 0. I do a u substitution. Magic happens. The t squared cancels with the t squared, so magic is happening. And the 2 is divided by minus 12, and we get another factor coming up here when I do the integration. So this is the expression I get, and I'm going from 33 to 1. I plug in the numbers. I plug in this number, and then I subtract, plugging in this number, but there's some minus action happening, and I get the same answer doing a u substitution. We got exactly the same answer, and this time we didn't have to worry about going back to t's in our answer. Here's example 2. You'll know what to do and when to do it, and in fact, why don't you copy these problems down and work them, or try to work them, before part 2. I'll see you in